All right, this video we're going to do section 8.3, which is split up into a bunch of days, but today's day one of it. Before we get into the main lesson, we're going to need factoring over this section quite a bit. So I was going to have you pause the video and see if you can remember how to factor these different situations. All right, so give them a shot before continuing. All right, so in a trinomial situation where it's x squared here, we can usually, not all the time, but usually we can factor it into x and x. All right, and actually I should look for GCF first, but there is no GCF, at least in these first two. All right, so I'm going to put x and x here, and then it multiplies to the 8 and adds up to the 6. So we could think about things that multiply to 8, and the pair that's going to work is 2 and 4. So this just is plus 2 and plus 4. So this statement splits into these two binomials. Okay, the second one is actually kind of similar in a way, except we have 0x in the middle. Right? So when we factor this one, when we break it apart, we still have x and x here, but then they got to multiply up to 9, negative 9, and add to 0. If it multiplies to negative 9, there's one negative, one positive value. That's the only way we'll multiply to a negative, and then we're just going to use sort of the square root of 9, which is just 3 and 3. Okay, in that case, by the way, it's called square minus square. Like if you have x squared minus 16 or x squared minus 49, any perfect squares, it's going to split. Right, like this one splits to minus 4 and plus 4. Okay, and this one would split to plus 7 and minus 7. Right, so that's just square minus square case. Okay, last one. There's a couple tricks on this one, right? So certainly there's a GCF of 3 and x. All right, but generally what you want to do is write it with the highest exponent first. Right, when you factor, it's going to be better if you write it with the highest exponent first. So I'm going to put the x squared first. Okay, and then pull out a 3 and an x. But also, if the front thing is negative, we're going to pull out a negative. So we're going to pull out negative 3x here. Okay, and you'll see later why that actually matters. But reversing these two, putting the highest exponent first, and then if the first thing is negative, pull out a negative. So that will leave us with x and then minus 2. I don't know why I wrote plus. 6 divided by negative 3 would be minus 2. Okay, and so that would be what it looks like in factored form. All right, so let's get on with our lesson. So 8.3, our big goal is we're going to graph rational expressions. Okay, I know we did them a little bit. We've already graphed like 1 over x. That was the like inverse one, but we're going to start to graph more complex ones. Okay, and so there's a lot of pieces to it, and today we're going to learn just one of the pieces, which is called like a discontinuity, like a break in the graph, kind of like this kid's brain is breaking here. All right, so let's get going. Yeah, let's skip that part. So a rational function is just like a polynomial over a polynomial. Okay, so here's a bunch of examples of rational functions. And so far, again, we've done the very basic one of like 1 over x. Right, that's pretty basic. Now there's going to be a little bit more complex polynomials. All right, and so domain in general, right, or basic for domain is all real numbers. Like if I have f of x equals just like 3 times x, the domain there is all real numbers. All right, because you can multiply anything by 3. X, you can literally put any number there for x, multiply it by 3, and you're just fine. Okay, so the domain is all real numbers. On a rational function for domain, we're going to have to watch out because the fraction bars divide, and we don't ever want to divide by 0. Okay, so when figuring out the domain, you've kind of got to think about like when is the denominator 0. All right, so I'm going to skip the first one for now, but basically if I look at this one and I look at, hey, when is this little expression in the denominator 0? If I set that equal to 0 and solved it, I would get negative 2. All right, so basically our domain here is going to be all real numbers except negative 2. Right, because you can't divide by 0, right? If x is negative 2, we'd have like 1 times 0 on the top, and then we'd have 0 on the bottom, and we'd be divided by 0, and it'd be a problem. Okay, so you could pause here and think this second one or last one here is going to be all real numbers except what? Okay, and so the answer to this is, again, look at when the denominator is 0. The numerator doesn't matter. You can have 0 on the top. 0 divided by 5 is just 0. You just can't have 0 on the bottom. Okay, so our domain here is all real numbers except 2, right? Because if you set x minus 2 to 0 and solve it, you get 2. Okay, and then the last example, so basically when you're figuring out domain, you're going to set the denominator to 0 and try to solve that. So on this one, if we solve it, we'd minus 1 and take the square root, and so we'd get plus or minus I. Okay, so that would create a problem, would be imaginary numbers. But our domain, again, we're looking just at real numbers. So our domain here is just all real numbers, right? The only thing that'll make the denominator 0 are imaginary numbers, and we're not going to really talk about them for domain. We're just going to assume domain is everything that's real, all real numbers. Okay, so these points, this -2 and 2 in this other example, these points are called discontinuities in the graph because you'll be going along making your graph and then it'll break at that point, right? You won't be able to have a y value for an input x of -2 because it'll be undefined. It'll be an error. So in the graph, that'll be a break, which is called a discontinuity. Okay, so this would be a good thing to write down, that when the denominator is 0, there's a break in a graph called, this is a big word that Mr. Westphal probably can't spell, but it's just discontinuity. That's my best guess at how to spell it, but that's a discontinuity in the graph. Okay, and so with these discontinuities, here's the pictures of the graph. So these are the three we were just talking about. So like this first one has no break, it's just continuous, right? All the way through, there's x points. Maybe I'll try a different color there. There's x points. There's y values for all the x points, right? The graph just goes on and on forever. So we have no discontinuities here. Okay, and then on this one we talked already about like x equal -2, right, is the problem. And so you can see this is what if you literally type this into Desmo, so this is what the graph will be. But we draw a hole here at -2 because when x is -2, y is undefined, right? Because x -2 makes divide by 0 and it blows up. Okay, so the point of discontinuity is x equals -2, but there's going to be two types of discontinuities. Okay, so the first example you see here is called a hole. It's literally just like a donut or a hole in the graph. All right, and then on the second example, again, we already talked about our discontinuities at 2. So our point of discontinuity is x equals 2. But this time, if you look at x equal 2, it'd be right here. There's x equal 2. There's not a hole. There's a vertical asymptote. Right, so this is going to be a vertical asymptote. Okay, so basically when you have a discontinuity, there's two different types, holes or vertical asymptotes. All right, and so how you can tell, all right, how you'll be able to tell is if this little factor that got us the -2, if it has a matching factor up top, then it's going to be a hole. So basically the difference is this one has a matching factor in the numerator. Okay, versus this little factor x minus 2, there is no match up top. Okay, and if there is no match, then it's going to be a vertical asymptote. Okay, so that's a lot of information thrown at you at once. But I think as we go through some more examples, it'll make more sense. Okay, so we're talking about the discontinuities in the graph, and there's two types. Okay, so let's do some more examples. So all of these things are really tied together. Okay, so I'm going to do this first one with you. So when we talk about the domain, it's going to be all real numbers on these ones except when the denominator is 0. So I'm going to go over here and set my little denominator to 0. Okay, and you could certainly, let's actually factor it. Let's just factor it to x minus 4 and x plus 4. Right, that's the square minus square case again. Okay, and now if you set each thing to 0, we're going to get two discontinuities, two breaks in our graph. So this one would be +4 and this one would be -4. So those are called our points of discontinuity, x equals 4 and x equals -4. All right. And then to figure out, so now we want to talk about the graph. Like, so if we are graphing this thing, we know there's going to be a break at -4 and 4. But what will they look like? Will they be asymptotes or holes? Okay. And so basically we got to look, right, this x minus 4 and x plus 4, that was what our denominator really was. Sorry that I'm having a hard time writing it there, I'm out of space, but that's our denominator. And we want to look, do these little factors have a match up top? Okay, so this is kind of the key slide. If it crosses out and has a matching factor, it's a hole. If it doesn't, it's an asymptote. Okay, so our denominator is really simple. Sorry, our numerator is simple. It's just 1. So there's no matching x minus 4 or x plus 4 up in the numerator. Okay, so both of these, if I label these, this x equals 4 is going to be a vertical asymptote, and so is the minus 4, right? Because there's no match for either of them. This graph will have 2 vertical asymptotes. Okay, so we're not going to actually graph yet, but basically you're going to have 2 vertical asymptotes at 4 and -4. So the graph will actually look something like this. I don't really know what it looks like. I'm just making this up. But it'll have breaks at 4 and -4, and it'll have asymptotes at those spots. Okay, and really to make the graph, we're essentially going to use our calculator, but we want to draw them somewhat accurately. And so one of the things we want to draw in our graphs is vertical asymptotes and holes. So this one just has 2 vertical asymptotes. Okay, I'm gonna skip that one. Let's try this one quick. So pause the video and see if you can figure out the domain discontinuities and then are they holes and asymptotes. Try as much as you can on your own. Okay, so my first step is I want to know like when is the denominator 0, and so to figure that out, I'm going to factor that denominator. So basically, this is why that factoring matters so much. And we put x and x, and luckily everything's positive, so we know it's 2 pluses. It's got to multiply to 2 and add 3. So this is pretty straightforward. The only thing that multiplies to 2 is 2 and 1, and then it'll add up to 3. Okay, so now that we factored it apart, we say, okay, well, when is the denominator 0? So either the first part could be 0, this is a multiply. So either the first part could be 0 or the second part could be 0. And if I solve those, this would give me -2, and I don't know why I wrote the parentheses there, but that'll give me -1. Okay, so our domain then is going to be all the real numbers. X can be anything except those 2 numbers, -2 and -1, right? Because those would create a divide by 0 error. Okay, so when we make our graph, there's going to be 2 points of discontinuity. The graph's going to break at -2 and -1, right? So if I start to think about the graph, right, our big picture goal is to graph. We know for this particular graph, there's going to be breaks at -1 and -2. Right? So the next piece then is, are they going to be holes or asymptotes at those points? Okay, so again, we got to figure out, like, so here's -2, and we got to look, does it have a match up top in the factors, right? Is there a matching x plus 2 up here? And the answer is no. So we're going to have a vertical asymptote at -2. Right, so I can draw that right in right now. Okay, and then at -1, there is a match. It crosses off. Okay, so this one's going to be a hole in the graph. Right, so when we make this graph, I'm going to start to draw it, right? We'll have a vertical asymptote there, and maybe down here it'll look like this, right? And then I'm going to draw at -1, I'm going to draw a hole. I'm not going to draw it on the x-axis. I'm going to draw it in my graph and say, you know, I have a bunch of points, but when I get to -1, there is no point there, right? So we just draw a hole at -1 and an asymptote at -2. Sorry, that's not clear now, but that's -1 in my graph. Okay, that's it. I'm probably going to make another video going over a couple more examples because this is pretty complex, but that's it for part 1 of this lesson.